Hello, it's Widiana Sabah, and in this video, I'll be explaining my parametric design model, which is the Beijing National Stadium or the Bird's Nest Stadium, located in Beijing, China. And it was designed by Herzog de Meuron, Arab Sport China Architectural Design and a research group. Also, it was built with the primary objective of being the main stage of Olympic Games. And the concept or the inspiration of this project was the bird's nest. And this is the final model that we will explain in this video. So the first part of the model will be the mass, and this part will explain how to generate the mass using Grasshopper. So starting with ellipse curve and scaling it with the graph mapper, and here we can set the number of curves we want. And then rescale this curve again using the scale mu, so we can stretch the curve or make it more oval. And then we move these three curves also using the graph mapper. And this part is totally parametric, so we can change the heights of the curves and also their sizes. Also, there is another way to generate the mass, which is by using congruence. So in this part, we will have two anchor points. The first anchor point will be with these two curves, which are the base and the top curve. After moving them and moving and scaling them, we will convert the surface into a mesh to take the naked vertices of these two curves as our first anchor point. And for the second anchor point, will be with the middle curve. So in this part here, it will explain how to snap some points in the mesh to this curve, and that by dividing the mesh into a strips and take the closest point of the boundary of the strip and snapping it to this curve and have it as our second anchor point. And now we can see the result. And the second part of generating the mass using Kangaroo will be smoothing the mesh, as we can see the sharp edge here, and lower the top part. And that by exploding the mesh and deconstruct the normals based on the z direction. And that by using the equality with tolerance battery, you can find it in pufferfish plugin. So basically, this battery will select normals based on the z direction. So here we end up getting the top and the second or the bottom part here. For the next part, we will take the naked boundaries of the mesh, and for this curve, we will plug it to the anchor XYZ and have the toggle on true in X and Y. So it will prevent points from moving in X and Y direction, but only move in the Z direction. And we can see here. And then we join the upper part with the lower part and smoothing them. But I will continue with the mass that we generated using Graph And the next part of the model will be the steel panels. In this part, we use the sphere and populated 3D to generate random points around the surface, and then beat up a plane to create those curves. And here we can change the number of these curves. And then to have the thickness for these curves or section, we will use a perpendicular frame and then rectangle to have the thickness for them. And also we can change the thickness here by using the domain of the rectangle. The next step of the model will be the surface splitting. So after we split the surface, we deconstruct the area in the z direction and then cut everything larger than 37. This is parametric too. We can change it. And then we extruded this part here. For the physical simulation part, this part will show us how to bubble these panels out, and that by using or by deconstruct the surface and cut everything that not smaller than 44. So we will end up getting all these large panels. And of course, we can change the number so the size will change too. And then I converted this surface to a mesh and then triangulate it. And then I use the flip battery. So I will flip the mesh to bubble out this way, not inside. So this is the last part of the model, which is the stadium stands. And for this part, I use the ball builder plugin. Line. And then I have these three gene pool, one for the rows, one for the cantilevers, and the other one is for the C values. So the one with the rows is basically how many rows in each level, and right to click on it here to define how many levels you want. Basically, these are the viewing angles section, and then we have these curves, extrude them.